Swayam Prabha. Digital India. Educated India.
Welcome to the online certification course on structural systems in architecture. Today we are in the module number 8, 8th week, special structure, and today is the 40th lecture, the last lecture of this course. The topic of this lecture is structural detailing. Of course, in the end of this particular lecture, we will briefly sum up this particular course on structural systems in architecture. The concept will be covered in this particular lecture. Some of the concept we will start some introduction on the detailing, and then we will discuss the very primary or preliminary type of detailing on of beams, column, foundation, and the RCC slab, and those detailings are of the reinforced concrete structures. So, the learning objective of this particular lecture will be, we will introduce the needs for the detailing, the why the detailing is required, and one after one we will discuss some of the general detailing and the common structural elements. So, first let us introduce the detailing. The detailing is come in the final stage, and that will be followed by the design. In structural design, the last stage is called the detailing stage, and in that particular stage, what we will do? We will do the incorporate all the needs that is required to follow a particular standard rule after the design of any structural element is completed. So, structural design gives you the amount of steel, amount of concrete, the sectional area, all those typical parameter, but the detailing gives you the some of the standard norms, how that amount of the steel and how that can be provided in a particular element. The detailing of the reinforcement or the rebar is depend upon the following important factors. So, it is vary from the maybe from the same design or same type of the loading, it may vary. One is from the strength of concrete and the steel, because of the changes in the strength, the detailing will going to vary. The condition of the support system, because as you know, the support systems are sometimes it is largely apart, sometimes it is very close by. Because of that, the system of detailing may change. The type of loading system, that is maybe it is a static loading or maybe a dynamic loading, we have to check that one, that what type of loading a structural element may I mean that kind of a load may be applied in a particular system in the lifetime. So, based on that there will be slight change in the detailing. The bonding and the development is one of the prime criteria for the detailing. That bonding means, suppose a particular rebar, if I draw here, let me if suppose this is a particular concrete element and there is a rebar or the reinforcement bar. So, how much this much, I mean suppose this bar is under some kind of the tensile pull. So, the bonding between this concrete and the steel will try to attach, I mean try to make this particular the attachment between the two different material static. Okay. So, if there is a suppose the bar is can take more and more amount of tension, but there is a problem between the bonding between the concrete and steel. So, there will be definitely the concrete the bar will come out from the concrete. So, how much is the length, this much is minimum length is required, that is one of the questions. So, that is the bonding, and due to this bonding we can develop some kind of the development length, how much length this L is required to possibly require that kind of the bonding strength against the actual amount of tension that has to be taken care of by the steel bar also. So, those are there. So, we have not discussed that one in detail, because that is a purely come under the civil engineering domain. So, we do not bother about that. The civil engineers and the structural designer will definitely help us to calculate, and from the code they will find out how much is the development length and all. And but we should know that the excess amount of steel sometimes they are giving, and that is due to that the development length or so. Then there are curtailment of the reinforcement, that is some reinforcement may cut, because of that is unnecessary in some of the portions, and some of the portion it is necessary. So, even though we can cut it in some portions of the reinforcement. So, what are the codal provisions, how much is the length we have to we may not apply any kind of a cut or whatever, though that has to be also can be work out from the detailing, and we can draw finally. And the standard of ductility in the structural element. The ductility is one of the prime or criteria for any structural element, because out of this two, in case of RCC the concrete is not at all ductile, it is a brittle material, and whereas the steel is a ductile material. But if I want to have the total composite structure as a ductile structure, so there are some norms, norms has to be followed, and that norms has to be comes from the detailing. It is not directly available in the design stage, or through design we cannot actually ensure the ductility of a particular structure. So, those are the detailing. Detailing is very important. So, I will go to the next slide. So, this is the handbook on concrete reinforcement and detailing, which is also known as SP 34, and this is IS standard, the Bureau of Indian Standard publication, and this can be followed. This can be followed for any kind of detailing of RCC structure, general RCC structure. This is a vast collection of the lot of detailing diagrams and all. So, the engineers and the structural engineers follow, the architect read from their drawings and all. So, we also will going to follow this particular handbook for my this my lecture for the slides to come. So, now next is the necessity of the structural detailing. Why a structural detailing is required? So, I already designed a beam already, and then why this detailing is required. The first one is, it will provide a common benchmark to apply the design findings. Common benchmark means, I mean, suppose I am a designer. So, I found some the rivers, amount of rivers or so, and there is another somebody, maybe you are another designer. So, when you design that one, so you also find the probably the same amount of steel or so, but when we apply it to a drawing, that this is the amount of steel and this is the curtailment, this will be the bend in the ends or so. If I go with in my way, and if you go with your way, that will be not be a kind of the uniformity. So, there is a benchmark is required. That benchmark will ensure that the things are proper and things are uniform. So, that is some of the first the necessity, and then it will provide a common uniformity over the nation or the region to specify a design output or standard norm. So, just what we can pick up from the first point is it is required uniformity over a particular nation or particular country, region, or sometimes subpart. So, that then this same type of standard follows. The third one is also very important. It can bypass many more in-depth calculation in design stage to reduce the effort of the design process. So, design process first the first primary target is to find out the section depth and the width and all those geometrical parameter and the amount of reinforcement. That is the primary achievement or the goal of a designer. And then, as I told in the last the slide, that there are development length, there are curtailment, and all those if you do for every section of the beam or so. So, your total process of the design will be too long, and due to the too long process, you may sometimes require more effort, more manpower, more effort, more man hour involvement, but those can be tackled in a very smooth way or very typical way by the detailing. So, there may be a kind of a standard procedure, which standard procedure came definitely from some of the research and some of the cumulative computations, and they give you some kind of a the kind of the standard procedure, and you follow that standard procedure after that, after your design the primary elements, and you can go ahead with your process, finalize your design process also. Detailing is printed in drawing sheet and sent for the execution. Yes, that is the one of the most catchy point in the detailing. See, if you your detailing your the after design, that how many bars, what will be the distance between the bars, and everything if you follow, and that will be actually draw by draftsman or somebody else, and that will be printed, and that will be sent to the execution for structural execution. So, the people will actually see, not you will, they will not going to see your design sheet, they will going to see the final the drawing sheet that actually comes out from the design office, and when it comes out from the design office, it goes through a detailing section, and then it comes out, or maybe a detailing and drawing section. So, that is why detailing is very important. So, if anyone in the detailing sections, or maybe the anyone in the site may misread that particular design thing, or there is a gap between the design and detailing and the site execution, there will be a problem. So, it is very important that the final printing or your design has to come through the detailing part. The last but not the least, without detailing of structural items, it is not possible to quantify the exact amount and cost of the steel and concrete on the project. Yes, because as you know, a project cost and the project estimation is based on the final design diagrams, working drawing, if in case of the non-structural element, and for the structural element your the structural detailing sheets. So, exact amount, how much is the bend, how many are bent, how many are curtled, how many are actually going with the top reinforcement, and how many are stopped in the bottom reinforcement. So, all those is clearly readable from the your detailing sheet, structural detailing sheet, and based on that you can estimate, and you can actually quantify how many tons of this reinforcement or rebar is required, how much quintals of your concrete, or how much meter cube of concrete required, everything you can finalize from that particular thing. I mean, exact detail estimation is possible. So, now let us go to one by one. Let us first go to the detailing of the beam. In the detailing of the beams, you see there are if you go to that SP6 SP34, there are full of 10-15 pages on this detailing of beam. So, we do not have that much time to discuss all those, but we will definitely go through few of them, and you can sense that what are the detailing and how the engineers do the detailing, and how it will be readable from your point of view, from architect's point of view. See, there are some minimum distance between the bar, that is the criteria. I just taken those things from the cropping from that particular PDF file. You can actually Google it in your this one, sorry, this one, yeah, this one you can Google it, and it is available in the net, the free version of this particular PDF file, and you can go through. I have actually taken out that cropping those some of the things, may not be in very well sequenced, and then try to give you a kind of a glimpse of that. See, if you see the distance between the bar, see, you have designed, suppose you have designed 5 such bar in the in your tensile zone of the beam, and those 5 bar will be 5 bar is the design output, and how it will be arranged. Is it will be arranged in such a way that there is no gap, or it will be overlapping with each other. So, no, there are some rules. So, that rules has to be taken from this particular detailing code. So, the horizontal distance between the two parallel bars. So, that means this distance I am talking about, this bar, this distance, what will be the distance is the dia of the bar, the minimum, not less than the following, the dia of the bar, diameter of the larger bar, if there are unequal bars, suppose the bars are not equal. So, then the highest amount number of bar are 5 millimeter more than the nominal maximum size of the core segregate. So, suppose this is the core segregate size, which generally we take as 25 mm nominal size. So, that means more than, so that means 5. So, that means it will be almost about 30 mm. So, the gap between them will be the 30 mm. Some of the reinforced concrete cases we can take the 20 mm size. So, in that case it is 25 mm will be the gap. And suppose I am going to use the 16 dia. since out of the 16 and 25 the not less than. So, I have to take the 25 as a the distance between the center the gap between this particular two bars. Okay. And if there are two such layers, suppose there are heavy amount of reinforcement. So, one layer cannot be accommodated because there is a width provision, you cannot just increase the width like to a maximum. So, there is a restriction, the architect gives the restriction of the width of the beam, because they do not like to have the width of the beam too high, and that create a kind of a visual problem or those kind of a serviceability problem issues also are there. So, in that case you may have to arrange, and suppose that beam is too large and it is a heavy beam bending moment. So, there are number of bar is much more. So, one line you cannot accommodate, because one line that criteria of 30 mm or 25 mm if you space, if you give the spacing between them. So, it comes out to be a very very large this thing. So, then we can go in a two layer, and if it is a two layer, then the vertical distance is come into the picture, and the vertical distance is between the bar shall be 15 mm or 2/3 of the nominal size of the aggregate of the maximum size of the bar, or the maximum size of the bar. So, maximum size of the bar is, suppose it is 16 mm and 2/3 one is 2/3 of the aggregate size, suppose it is 20 mm. So, it is almost about 18 6 almost about 12 13 mm or so, and suppose the 15 mm. So, out of that which is highest? Highest is 16. So, this gap has to be 16 mm or so. So, the like that we have to actually see that the which criteria is fulfilled. There are always, if you see this spacing and the amount of the stirrups and all those, the length and all, there are two or more than two criteria, and out of that we sometimes have to select the highest number, or sometimes you have to select the lowest number. So, that is the spacing, and then if the side face reinforcement, that is another criteria. Suppose your beam depth is too large, suppose it is too large, suppose you want to go for a larger depth beam, because again the bending moment is very high, your span is very high. So, but you are designed that beam as a single reinforced beam. So, you have a you have that reinforcement in the bottom layer, or sometimes you may have some double reinforced beam. So, you may have the reinforcement in the top layer also, but if the depth is exceed 750 mm, see what it is written over here, depth is exceed 750 mm. So, you have to give some additional bar in as a side reinforcement. This is called the side reinforcement, because of why side reinforcement required, because number one is to hold that stirrup, that shear reinforcement, that is number one. Number two, that side reinforcement is required because there will be sometimes a crack comes because of the shrinkage or the thermal expansion. So, to protect that one, there will some tension develop due to that thermal expansions also. So, to nullify or neutralize that tension, we may give sometimes the side reinforcement. So, total area of those side reinforcement shall not be less than 0.1% of the wave area. So, you know this is the wave area, this is the flange. So, this is the wave area. So, you have to find out how much is the 0.1% of the wave area, and equivalent to that the two bars equal number of reinforcement has to be given in the two side exactly at the center probably, and then that two bar has to be identified, given as a side reinforcement. But another important thing is that this is another important, they have given another clause, the spacing should not exceed 300 mm or the wave thickness whichever is less. Suppose this depth is more than 750, suppose this depth is too high, suppose 900, it is unnatural, but sometimes it may be some deep beam and all, we can go with that kind of the criteria. So, in that case 900. So, 900 if you just put in the central, so it is 450 450. So, this is invalid, it is not going to valid 300 mm. After 300 mm you have to give 1. So, 750 it is okay, the half of 750 is definitely, in case of that there is a wave or so. So, it is okay, but if it is more than 300 distance between the wave, the distance between the bars, then definitely it will be, you have to go with another layer of the bar, but 0.1% wave criteria will remain same. Then next the stirrup or the shear stirrups reinforcement, you know that the stirrups are actually practically given in a beam to resist the shear force. So, in the shear force we have different type of stirrups. We can usually go with the double leg stirrup, which is having the diagram is given over here, and there are some multi leg stirrups also, where we can go with sometimes more than 2 legs. So, suppose there are 4 or there are some bars like that. So, we may have some kind of a stirrup. So, this is a multi leg stirrup, there are 1, 2, 3 leg stirrup, like that we can arrange the multi leg stirrups also. And here also we have given some kind of they have given some kind of a maximum spacing of the stirrup, which is shall not exceed 0.75 small d. Small d is nothing but the effective depth for the vertical stirrup. These are all of the vertical stirrup. D, and for D it is the inclined stirrup 45-degree angle, but generally we do not go with that inclined stirrup also. But in no case it should not be exceed 450 mm. So, that is the maximum bar. You cannot have the more than this 450 mm, you cannot exceed that one, 0.75 d or the 450. And there are different type of arrangement, how the lapping has to be done, everything has been mentioned over here. So, we can generally follow the first one or maybe the second one, like that. So, there are some kind of a hook will be created in the corner to just to make that, ensure that that stirrup is well hold with your stirrup holder or those bars. Now, one thing is very clear, that if it is a tensile reinforcement, or sorry, I mean it is a simply supported case, the tension comes in the bottommost zone. So, those are your the design number of bar or something like that, but stirrup are actually hold in the top. Okay, the top bar, there will be two, definitely there will be two corner, there are two top bars. So, stirrup will be actually hold and bend and all these things will be actually governed in the top direction, which is not design part, that is compression zone of the concrete. Those steel actually associated with the holder or those hooks, that is very important. So, here are some kind of anchorage, anchorage of the stirrups. So, how it will going to anchor, that is also given. You see that every small and individual details has been given, and based on that under the supervision of the structural engineer, a draftsman can draft those drawings and all. So, a stirrup may overlap, anchoraging overlap may be like this 90-degree overlapping, and in that case if the phi is the dia of the bar, which is it will going to I mean the bend, or it will going to actually anchor. So, it will be actually exceed or produced by 8 times the diameter if it is 90-degree. If it is 45-degree or maybe 135-degree, whatever you may say, that in that case 45-degree from the center line, then it is 6 phi. So, there are little less, and if it is a I mean totally 180-degree kind of a case, or it is just a kind of a sweeping kind of a character of the anchorage, then it is 4 phi. So, 4 phi is your anchorage dimension from the center of that. So, now you see that these bars are extra amount of bars. So, you know these bars are extra. So, this is your the 4 phi. So, suppose the phi is your suppose how much. So, suppose phi is your 16 mm. So, this 4 phi is your almost about 64 mm. Extra amount of bar, extra amount of steel is required for one side, and here it is also 64 mm. So, into this into 2. So, this is 128 mm. Plus there are some criteria, from here there is a bend and there from here there is a bend. So, that is some extra, I mean that is also there in the code, I have not taken it up, suppose that is some extra. So, it is almost about 140 mm or 150 mm is extra amount of millimeter extra amount of bar is required, other than the perimeter of that, right, for that particular hook. So, that 140 or 50 mm extra is required for each stirrups. Each stirrups require that much extra, and you know how many stirrups are there in a particular beam. There may be in a beam maybe 20 stirrups, sometimes it may be if it is a big, or there is a kind of the shear force is too high, it may be 40 stirrups or something like that. And there are how many beams in a particular beam in a building, in a particular good building, or in a project or kind of a thing, maybe your hostel or maybe your institute building, how many beams, there may be 100 beams, 130 beams, something like that. So, that then how many this 150 in one stirrup, 150 multiplied by your suppose 30 stirrup in a beam, and then there is 130 beam. So, those much amount of extra length of the reinforcement is required just to make a kind of a stirrup hold. Right, and then that has to be estimated properly. Otherwise, if you do not estimate that one, your total cost of the project will be less, your total the estimation will be wrong, and then whenever you come whenever you actually order those materials for the site, and at certain point will be shortage of those particular material. So, that is why, and it is the detailing and all these things is very important. This is the requirement of the reinforcement. So, reinforcement requirement is also there. So, how much will be the tension reinforcement, the minimum and maximum criteria. This B and D, the D is your the depth of the beam, and this is the design compression depth. So, everything is mentioned over here. There are curtailment criteria also. So, how much you can curtail. So, the tensile zone, the 100% bar moving over here, and there is a curtailment at least at the point 1 L1 is the effective length. So, 10% of this you can curtail, maximum 30% curtail, you cannot curtail more than that. So, similarly, in the support, you know, there are more reinforcement is given in the near the support. So, how much is the curtailment? So, for 20% you can curtail in the center of the span, 20% will be remain, actually 80% can curtail in the center of the span, 60% you can curtail at a distance, 25% 0.25 L1 like that, and 100% you can keep in this particular 0.15 L1. So, everything is very clearly mentioned and given in that particular the diagrams and all. So, detailing of the column is also given some kind of a detailing. So, how much is your cover. So, I have forgot to mention in the beam there are cover criteria also. The cover of the is this cover to the steel is 25 that is required to protect the steel from the corrosions and all. 25 is for the beam, 40 is for the column. You see in the fall column it is 40 and how much is the longitudinal bar also. This is another very important criteria, is that the bar of the longitudinal steel should not be less than 12 that is another very important criteria. So, even if you have very less amount of steel requirement and you can go with the suppose the 10 bar is not absolutely not permitted. The amount of steel reinforcement, longitudinal reinforcement should not be less than 0.8% and should not be more than 6%, but in general we can go with it should not exceed 4%. Otherwise, if you exceed 4% steel in the column, it will be so densified that you cannot put the concrete, the aggregates very easily. So, these are the some of the criteria for the hooks and the ties. So, those are the three criteria, that least lateral dimension of the compression member, 16 times the smaller dimension of the longitudinal bar, and the 48 times the diameter of the transverse bar. So, transverse bars are the ties and this is the longitudinal bars are those. So, that is also mentioned over here, that this particular pitch criteria. So, you can see those and you can try to understand. Foundation, the foundation the clear cover is 50 and in side cover are for 75 or so. So, there this development length. So, this particular things comes and that column reinforcement that goes 300 like that. So, those are also given, and suppose the slab reinforcement also. I am going little fast because we are running short of time, but still just we can see that these are the slab reinforcement for one way slab. So, there are anchorage or sorry the bent bar in the corner, and this bent bar are located in the at the near to the support at same point 1 L. So, one bar is running through like this and then bent, another bar is coming like this and then bent. So, if you just take the section BB, which is this, which all bars are in the down, I mean in the bottom part, and if you take the section AA, which is this, so some bars are in the top, in the flank. So, this is there are some bars are in the top, right. So, if it is a two-way bar, then both the sides it is going to be cranked and 0.1 L, 0.1 L like that, and both the cases you can have that the cranking of up, and how much is that the cranking and how much is the distance is everything is mentioned over there. So, that is all for my course, and we just give you a small brief is that we have covered all the 8 chapters, and the first 4 chapters is basically based on our some of the calculations, some of the basic understanding of the force, bending moment, equilibrium, stress, deflection, and the frame structural calculations and all. And the fifth onwards, through this particular lecture, we have gone through different type of structural systems, starting from the truss, then the arch shell, tensile plate structure, and the temporary structure, then the high rise building foundations also, those have been taken care of. So, hopefully you have understood that, and then we will now going to have the final end semester examination. The end semester examination will be very simple, and if you have done your all the assignments and the homework problems and all, I won't see there is any problem in the end semester examination. If you check the standard of the end semester examination, it will be almost equal to your assignment test or so, or maybe little bit lower. In fact, I will try to put the questions like that. And there are different types of question, as you know. I have already given those questions in the your the assignment. There are questions of multiple choice where one answer is correct. There are some multiple choice, there are 2 answer or 3 answer are correct or something like that. There are some questions where there is a serial, I mean there is a question number 8, 9, 10 are based on one kind of a statement or so. There are some question you have to numerically put the values, suppose that this value is 15 or kilonewton or so, you have to write 15. So, if you write 15 and then you will get the right answer, and then you will get the marks, or so if you write something else it is wrong. And there are some the essay numeric or alphanumeric type of questions also, where you can have some questions from, like you have to type that, you have to write the word in a say in a word form, suppose it is the tensiles or something like that, the compressive, something like that. Okay. So, before we finally end, let us conclude with that this particular being architect, you are going to expose to the structural systems many times in your life, and you have to make a clear dialogue with your counterpart structural engineer. So, that is why this course was designed, and that is why this particular initially I have started with some kind of basic calculations and the basic principles of structural mechanics and strength of material, and then we jump over to the different type of kind of the systems or so. So, you have a broad, I should not say you have a depth knowledge now, but at least you have a broad idea about the system, structural systems can be applicable to the architecture, but now it is your innovations, your thought, because you know it is a kind of the creative discipline. Architecture is a creative discipline. Now, your creativity has to be actually merged with your the structural knowledge and structural adaptability, that how that your creativity, you are creating something, you are creating a beautiful roof form. So, how it will be structurally feasible to I mean give you the kind of a support systems and all those kind of a the normalization of the stress and all those kind of a thing. You have to visualize that one, you have to actually, that required kind of the practice, that requires some kind of the more reading, more knowledge, more discussions with the master architects, and more discussions with your the counterpart of the civil engineers, structural engineers or so, and that definitely help you in the future. That is all for today. This is the only book I have referred for this particular lecture, this is SP 34, and that the conclusion remark is that this particular the structural detailing is linked in the with your site, and a structure may collapse because maybe collapse, you know, that it may collapse, it is a good design, but it may collapse due to the very bad detailings also. That is very important. There are a lot of cases we have seen that the structure has been good designed, but bad detailing, and there is a problem. So, that is the end of the course, and that is the end of the lecture number 40. Thank you very much.